All right, gents, good morning. Hey, before we get into anything that is relative to environmental science, we're going to do a brief little kind of lecture on objective truth. That is to say, scientific literacy, because science seems to be getting a bad rap nowadays. So before we get into the nitty-gritty of the course, let's talk about how things become actually objectively true. And the goal is, I guess, is to get you to think in a cosmic perspective. That is, which links you to everyone else around you, to everything else around you in the past, present, and in the future universe. So real thinking now, is not about acquiring a ton of stray facts where you go on Jeopardy and win a bunch of money, but it's really about learning how to problem solve and to think creatively, right? Scientific literacy is not so much about what you know, but it's about training your brain and wiring it for thought, right? And wiring it to ask the right questions. So that's what scientific literacy is. That's what objective truths help you to get in front of. All right, so think of an objective truth or science as a whole, right? Like studying a new frontier, right? You're there, everything in front of you is unknown. You don't have any answers. You don't even know what questions to ask at this point. So one key in recognizing the importance of objective truth is that it's bigger than all of us, right? And ultimately, nature is the judge, jury, and executioner. You can argue all you want, but if nature doesn't agree with you, well, then you know what, guys? You're wrong. So it's important to distinguish between personal truths, in other words, what your religion tells you, for example, and objective truth, right? You can keep believing what you believe, but if your belief your belief in it doesn't make it objectively true, right? All right, the good thing about science is that it's true whether or not you believe it. Scientists don't really set out to prove things, rather they test ideas that are repeatedly verified, right? Repeatedly verified by others, so until there's no need to keep doing so, right? So no matter what you're testing, you want to use the scientific method, right, to problem solve, in a problem-solving approach that helps you glean a reliable evidence in support of any hypothesis, right? Okay, so how do we get there? I'm still fumbling with technology. Right, so how do we establish, there you go, objective truths, right? First and foremost, science doesn't set out to prove anything, all right? Rather test ideas, right? And we use a scientific method, right? Observation, question, hypothesis, experiment, results, conclusion, things, the scientific experience, something you learned probably in the first grade, right? If you haven't, well, here's an example. I make an observation. My car won't start. Question, is the battery dead? Then I can formulate a hypothesis. If the battery is dead, then jumper cables will help it to charge and the car will start, all right? So then you do the experiment, right? You hook up the jumper cables, you charge up the battery, right? You turn the car on and voila, the result is it starts. So I can conclude my battery was dead. Simple enough, right? All right, so note if you thought your car wouldn't start because there were gremlins inside of it, right? That was your hypothesis, right? Then you're gonna need to develop an experiment that is gonna test for gremlins causing your car not to start, all right? When that has been done thousands upon thousands of times, that is when we can say that we have a theory involved. So a theory is not some willy-nilly thing that we have, right? Theory is a very high form of scientific thought, right? It's not just a hunch, right? A theory is the highest level of understanding of anything that we have in this world, right? A fresh, unchallenged idea is not a theory, right? It's just another hypothesis, right? And then a hypothesis is going to need to survive numerous and rigorous rounds of experimentation and peer review before it ascends to a status of a theory, right? Again, that word theory gets thrown around a little bit too freely in this term. Like, well, my theory, well, you don't have a theory, you have a guess, right? And in some cases, if it's politics, it's probably not even an educated guess, right? So theory is, again, the highest understanding of everything we know. So hold off on judging any hypothesis until you know more, right? So let it be studied. It may be right? We don't know, but that's why we have the scientific method and peer review to make sure that happens, right? And when we start experimenting, right, it's almost like now we're uncovering layers of the unknown, right? We're observing that new frontier and exploring it and gathering new information, opening up new worlds, all right? It's cool. It's like it's an exploration. Should be fun. So how do we guard against sloppy thinking, right, and intellectual laziness? And the key to that is to be a skeptic, right? And to be a skeptic doesn't mean that you think everything is wrong, right? It just means that you question everything, right? And a proper skeptic, all right, questions what they're unsure of, but here's the key point, guys, recognizes when valid evidence is presented, right, you change your mind, right? You have to admit that you're wrong, right? And so an informed skeptic, right, has the ability to ask the right questions, right? It keeps us from being manipulated. Carl Sagan once said, extraordinary claims require extraordinary evidence. That's words to live by, especially in today's society, right? So how are you supposed to believe what is right and what is not right? So first of all, do not take eyewitness testimony as the ultimate measure of things. In fact, guys, research shows that eyewitness testimony is among the least reliable forms of evidence out there, right? You get the guy who probably had a few too many beers, and he's out there in New Mexico, and he sees a flashlight and automatically thinks it's a UFO, right? Not a really good eyewitness. There are many people in jail today based on eyewitness testimony that is, quite frankly, just wrong, all right? So we got people who are incarcerated, all right, that should not be incarcerated, all based on eyewitness testimony, something somebody thought they saw, right? So to get to good thinking, we have to understand that we have biases, right? We all have biases. I have biases, you have biases. We're human. It's a fault of ours. All right, but understanding your biases and assumptions is critical, right? Is critical to clear thinking and scientific literacy. All of us, no matter what our education or intellectual commitment or good intentions, are susceptible to these biases. First one we deal with is cognitive bias, right? The tendency to believe something even when we're smacked in the face with evidence that says otherwise, right? And this could be from our political beliefs, our cultural beliefs, our political beliefs, our religion beliefs. I probably said those twice now. But a great example of this is the coin flip, right? If I do an experiment and I have 1,000 people, and the goal is to flip tails 10 times in a row, right? And if you do that, you're the winner. So we start off with 1,000 people. They all flip the coin. 500 of them end up flipping tails. The other 500, they flipped heads, so they're out, right? And so we go to the next round. We have 250 left, right? Then we have 125 left, down to 50, 25, 12, 6, 3, 2, and then finally the last guy flips tails, one left, and everyone goes bonkers. This guy is so special. The media's over there. How'd you feel when you flipped that tails for a 10th time? And the guy, oh yeah, it felt very special. It was great. You know, I was feeling the flow, and I just knew I would do it. When in actuality, right, if I ran the experiment 1,000,000 times, guess what? I would have 1,000,000 people that flip tails 10 times in a row. So it's not all that special. All right, so given that evidence, I would change my mind that flipping tails 10 times in a row is actually not very special. All right, and then we have confirmation bias, right? That's when we seek out information that supports your own belief. All right, and you ignore any other data that suggests otherwise, right? Climate change is a great example of this, right? On both ends, really. More often than the climate change deniers, right? Climate change deniers will focus on two or three bits of evidence, or bits of data, I shouldn't say evidence, bits of data that suggest that climate change is not really going on. When we have countless scientific evidence, countless scientific experiments that have been peer-reviewed that says, yes, indeed, climate change is real, all right? So we take out, in other words, we take out what we want, right? And so all the hits were good, and all the misses we just kind of shy away from. We don't incorporate that into our piece of evidence. All right, so how do we correct for our bias? So first you need to train yourself to admit defeat. You have to be humble. You want to get closer to objective truth, you have to say to yourself, hey, I was wrong, right? In the face of new data, you have to say, I was wrong, all right? If you can't say that, you'll never be anybody who actually discovers things in this world, right? You'll never be a really true intellectual thinker, right? When you can avoid biases by being aware of your own belief systems, whether you believe your belief is for your religion, your political ideology, your cultural worldview, or something else, all right? If you recognize these biases, and you can admit you're wrong, right? When the evidence supports that you're wrong, then you'll become a highly intellectual thinker, right? And you'll discover, I promise you'll discover new things. So first of all is assumptions, right? We all have assumptions. Assumptions, unfortunately, often keep us from thinking clearly, right? Before Einstein came up with his general theory of relativity, the common assumption was that the universe was stagnant, right? Neither expanding nor contrasting. Einstein's equation allowed for a dynamic universe, but his idea was rejected outright from the scientific community at the time, right? Later on, however, Edwin Hubble, right, would show that the universe is actually expanding. It's risky to presume that your assumptions are correct. Always test your hypothesis, right? It took many years to realize that Einstein was indeed right, but after countless experiments with both Einstein's mathematical equations and Hubble's observations, it was concluded that, hey, you know, those assumptions were actually wrong. The theory of relativity does exist. So be aware of your assumptions. Don't always assume that you're correct. And then we have repetition. This, by far, gents, right, is the most dangerous, right, of all biases, right? And it's a huge weakness of our human sensory system, right? Political institutions, religious tenets, cults all use this. It's a form of brainwashing, right? So it's how dictatorships and cults operate, all right? It's their mechanisms. Think Nazi Germany, think Stalin, right? Think some political leaders of today, right? So always be skeptical of what people in power tell you over and over and over again. Chances are it's probably not correct, all right? So there's, if Joe Biffy out there is reporting things over and over and over and over and over again, you should probably do a little research to find out if he's actual factual or not. All right, so the good news about science is that there's a system in place that weeds out bias, right? Think of it as a system of checks and balances, right? When somebody does an experiment, right, it isn't taken as theory right away. It has to be put to the rigors of the peer system. So many thousands of scientists are going to recreate this experiment, and then if they all come up with the same conclusion, then that is published, right? Then it becomes objectively true. So being aware of your weaknesses and having a solid sense of skepticism will help you be cognizant of, in other words, and think a little more clearly, and hopefully, in the long run, will keep you from being exploited. All right, gents. I guess for you distance learners, we'll have another video for you shortly. Peace.